Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 62, and this problem asks us to draw the stepwise mechanism for this reaction of benzene with this anhydride in the presence of our Lewis acid and hydronium, which is just protonated water, or acidic water, you could say. So we see that we potentially have a Friedel-Crafts reaction going on here. We have a benzene that can act as a nucleophile, and we have something that we can make into a very strong electrophile by reaction with our Lewis acid aluminum trichloride. So just like before how we would use chlorine to attack the aluminum, well, oxygen also has lone pair electrons, so it can also attack this aluminum. So just like any other Friedel-Crafts reaction, the first step is to generate your electrophile. So this is no different. We're trying to generate our electrophile in this step. And remember, oxygen lost electrons, so it's going to be positive. Aluminum gained, so it's going to be negative. But now we need to generate our carbocation. So what can happen is oxygen doesn't really like to be positively charged. So it will want to pick up those 2 electrons from this pi bond. And in order to do that, well, this bond here between these 2 oxygen and carbon can break to make a new pi bond here to make a new carbonyl group, making a bond. When you make a bond, you break a bond. So this pi bond can break and go to the oxygen nucleus. And now if I label this carbon as the green carbon, you can see that now this green carbon is now our carbocation intermediate, and then this red carbon here is now our carbonyl carbon, and this oxygen is that oxygen there. So now we've generated our electrophile here, and this is resonance stabilized through the movement of these pi bonds. Now we can use this benzene ring to attack our carbocation intermediate. So now we have a carbocation now in the benzene ring being formed, and we can use any base from the reaction, any sort of base that's in the reaction mixture, to pick up this proton to reform aromaticity in our benzene ring. But now we need to also reform our Lewis catalyst. So here is where step 2 comes in, and that's with the addition of this protonated water. So we can use these 2 electrons to go through the oxygen nucleus and pick up this proton, making a bond. You make a bond, you break a bond, and now you do 2 things. You form water and you reform your Lewis acid catalyst. And now you form a carboxylic acid, your Lewis acid catalyst, and your water.